A great day to one and all. Before I start my talk, let me express my appreciation to the West Visayas State University College of Education and Circle of Mathematicians for this invitation to speak with you. And today, I will be speaking about a brief overview to sets. I am Kim J.C. Ensho, a faculty member of Iloilo National High School SPSTE. And suppose I would like you to think about this. What do you think is common among these objects? So I have here A, E, I, O, and U. And I believe that you know what they are. They are vowels in the English alphabet, right? And this is what is common among them. They are all different, but we know that they are vowels in the English alphabet. And this is an example that illustrates the concept of what we call set. And you might ask, what is a set? A set is a well-defined collection of things or objects. It could be numbers, it could be objects, it could be symbols. But what is very important is that they should be well-defined and that they should have a common characteristic. Using the previous example, we could say that the set, let us call it V, is the set of vowels in the English alphabet. Or we could say V is equal to this set. Inside the curly brackets, we have here A, E, I, O, and U, and we listed them. But we have to remember that listing of the particular members or things inside the curly brackets do not matter. In other words, the order does not matter in this case. Now, let us learn more about sets. Let us learn more concepts. And using this example, this V equals A, E, I, O, U, this V here is the name of the set. And usually we use capital letters for such. And the ones in red here are what we call curly brackets. And inside the curly brackets, we have here A, E, I, O, and U. They are separated by commas. And these are what we call elements of our certain set. And speaking about elements of a set, this actually refers to a member or an object contained in a set. So we could see here that the elements of a set are in fact separated by commas. And as much as possible in writing the elements of a set, no repetition is allowed. So for example, if there is AA, EE, I, or some of them are duplicated, then please delete the repetitions and just only write them once. And if you have here your V equals your set containing, is the set containing A, E, I, O, and U, we could see that E here is part of set V. So here we have E, it's part of set V. In fact, it's an element. And so we write this symbol. This is read as E is an element of V. This symbol here is read as an element of. Meaning to say, if you write the symbol, what you meant is that this particular thing or object is part of your given set. So here, E is an element of V, A is also an element of V, I is an element of V, and so on. But what about if I ask you, is X an element of set V? Can you see any X here? And the answer is no. So therefore, X is not an element of V, or in symbols, we write it this way. This symbol here, it's like this one. However, it has a slash here. this tells us that this is read as is not an element of. So this is read as X is not an element of V. Now, let us have a short exercise about elements or not element. Suppose A is a set containing 2, 4, 6, 8, 10, whereas B is another set containing 1, 4, 7, 10, and 13. We will write is an element of or not an element of in the space between the given to make the statement correct. So we have here 2 and we have here A. We could see that 2 is in A, so therefore we could say we should write this one to indicate that 2 is an element of set A. Now take a look at the second one, 8B. Let's check if 8 is in B. We could see here in set B that 8 is not one of them. Hence, we could say that 8 is not an element of set B. I hope this is clear with us. All right, moving on. Going back here to this V equals the set containing A, E, I, O, and U. How many elements does set V have? We could have 1, 2, 3, 4, 5. So this set has 5 elements. And this 5 is what we refer to as the cardinality of set V. And you might ask, based on the example I give you, what does it mean when we speak about cardinality of a set? Cardinality of a set simply refers to the number of elements a certain set has. And the cardinality of a set is always a whole number. That is, it's either 0, 1, 2, 3, and so on. It's never a fraction, or it's never a fraction that is not a whole number. We cannot have 4.5, we cannot have 3.7, and also there's no such thing as negative number of elements. So we have to be very particular about that. And in this case, since V has 5 elements, so there are various notations for such. We could write it this way. We have here N, and inside the parentheses, we have V, the name of the set, is equal to 5, or it's like the absolute value of the V equals 5. So these two notations could be used to give the cardinality of a certain set. And note that the notation used is dependent on the author. And probably there are other symbols or notations. And what's important is you stick to what your teacher is requiring you to give. Now, let us have an exercise. Let's do this. Let us find the cardinality of each set below. Supposing I have here A with elements 3, 6, 9, and so on until 30. How many do you think are they? So these are all multiples of 3, right? And if you would write everything, you will know that there are 10 of them. Hence, the cardinality of set A is 10, and it could be expressed using these two symbols. Now, how about set B? Take a look at this. B is a set containing 1, 4, 9, 16, and so on until 64. If you are keen enough, you could actually know that they are squares of natural numbers. Like 1 is 1 squared. When we say squaring a number, you multiply that number to itself. So 1 is 1 squared, 4 is 2 squared, 3 squared, 4 squared, all the way until 8 squared. Hence, we could say that the cardinality of set B is 8. I hope it's clear with us. And let's proceed now with the next slide. There are ways of writing sets. The first one is what we call the roster or listing method. This method is used or in this method, the elements are listed inside curly brackets. In fact, the example I gave you earlier is an example of the roster or listing method of writing sets. But aside from the roster or listing method, we also have what we call the set builder method or the set builder notation. The set builder notation is making use of a certain rule to write functions. For example, this one could be written as V equals the set is a set of all X. This vertical line is read as such that X is a vowel in the English alphabet. Notice that if it's X here, it should also be X here. If you use R here, you should also use R here. If you use J here, it should also be J here. This vertical line is read as such that. In some books, they use colon. So in my case, I'll be using vertical line here to read, and this is read as such that. And note that I use here is. Remember, if you are using the set builder notation, then this one should be in singular form, not plural. So you say is, not are, okay? So V here is the set of all X such that X is a vowel in the English alphabet. I have to emphasize English here because we have many kinds of alphabet. And we are sure that A, E, I, O, and U are the vowels in the English alphabet. To make it more specific and to make it more well-defined. Now, this time, I would like you to write the elements of the set using the roster method. So I have here the set builder notation. K is a set of all X such that X is an integer from 1 to 5. So roster method, we have to list everything, integers from 1 to 5. So the answer here is K equals the set containing 1, 2, 3, 4, and 5, because these are all the integers from 1 to 5. How about if we have the second one? Right, using set builder notation, E, which is the set containing 2, 3, 5, 7, and 11. And what do you think is a common characteristic of 2, 3, 5, 7, and 11? These are prime numbers. And so, in my case, I could express this as E is the set of all X such that X is a prime number between 1 and 12. And what is good with set builder notation is there is no single way of writing set builder notation. There are many ways of writing it as long as it fits the roster. As much as possible, it should fit to the one that you are trying to describe. Okay? Next. Let's have another concept here. Let's talk about universal set. A universal set is a set which has elements of all the sets one is concerned with and is usually denoted by the capital U. And aside from universal set, we also have the concept of subsets. That is, it is a set of which all the elements are contained in another set. So to illustrate what we mean by this of subsets, let's have this. Let's check this out. Let's consider your U or your universal set with 1, 2, 3, 4, 5, 6, and 7, and sets A with elements 1, 4, and 7, and B with elements 1, 4, and 9. From here, we could say that all elements of A are in U. How come? 1 is in A, it's also in U. There's 4 in A, 4 is also in U. 7 is in A, it's also in U. So we could say that all elements of A are in U. We can say that A is a subset of U, or in symbols, we have this one to indicate that A is a subset of U. How about for set B? Take a look for set B. For set B, 1 is in U, okay. 4 is also in U, we have here. However, the element of B, which is 9, is not found in U. So you could see that not all elements of B are in U. Hence, we can say that B is not a subset of U, or in symbols, this one. So you could notice it's just like you write the symbol for subset. However, you have to place a slash here to indicate that it is not a subset. In fact, the slash in many symbols in mathematics here indicates not. So if this is subset with a slash, not a subset. All right. Let's have an exercise for such. Consider U as the set of all X, such that X is a color in the rainbow. I hope you are familiar with the colors of the rainbow. We have red, orange, yellow, green, blue, indigo, and violet. And sets X with elements red, blue, and green, and Y with elements yellow and pink. Write subset of or not a subset of in the space between the given to make the statement correct. So let's have the first one, set X and U. We know that red, blue, and green are colors found on the rainbow. So all elements of X are found in U. Hence, we could say that X is a subset of U. However, for the second one, yellow, it's in the rainbow, but there's no pink as one of the colors in the rainbow. So pink is not a member of your U here. Hence, we could say that Y is not a subset of your universal set. I hope it's clear with us. And moving on, I would like you to try this. Supposing I would like you to give me a set, let's call it P, of whole numbers between 9 and 10. And you were like, maybe you're like, wait, what? And let me ask you this. Is there a number that satisfies the condition? Is there a whole number between 9 and 10? And the answer is no. There's no such thing. And this case portrays the concept of what we call a null set or empty set. And what is a null or empty set? It is a set with no element. So there's nothing inside it. So in symbols, we say P is equal to this curly brackets, but there's nothing inside the curly brackets. There's no element written there. In some books, they also use the symbol P equals this symbol. This is the Greek letter phi. And this is also to indicate that a certain set, P in this case, is a null set or has no element inside it. However, please do not combine them. Do not write P equals these curly brackets with a phi inside. This is not null set. In fact, this is a set whose element is phi and therefore has a cardinality of 1. So this is not a null set. So we have to be very careful for this. To visualize the relationship among sets, a Venn diagram may be used. Maybe you have heard of this. A Venn diagram is an illustration that uses circles to show the relationships among things or finite groups of things. So supposing you have here, I have here, so you see in this Venn diagram, we have here a rectangle, and let's name that as our U or our universal set. Note that all of the elements in the universal set are understood to be within the rectangle. And you could see that A and B here are lying completely inside the rectangle, which tells us that A and B are actually subsets of U. And you could see that set A is represented by circle A. Set B is represented by circle B, and they are actually interlacing. In this case, there is a portion here, or a region, or this one, which is in fact common to both sets A and B. And if there is a region or certain elements common to both two sets A and B, then we could say that they are examples of what we call joint sets. Two or more sets are joint sets if they have at least one element in common. How about for the second one? If you could see here, I have here set X here, and we have here the other one is set Y. And if you could see, they are not overlapping, which is telling us that X and Y do not have a common element. And if two or more sets don't have any common element, then they are referred to as disjoint sets. All right, so I hope the definition is clear with us. This time, let's have a short activity about Venn diagrams. Let's have this exercise. So I would like you to make a Venn diagram for each pair of sets below and classify them as joint or disjoint sets. So I have here A equals 1, 2, 3, and B with elements 5, 7, 9. We could see that there is no element in common. That's why we have to draw them as separate circles. So here A, you have to indicate the name of the set. So we have here A with elements 1, 2, and 3. And all the elements here should be written within the circle A. And for B, we have 5, 7, 9. And all the elements of set B should be written within circle B. So we have here 5, 7, 9, B. And since they are not overlapping or they don't have any common element, then these two sets are disjoint. How about the second one? C equals the set containing 3, 5, 7. And D with elements 7, 9, and 11. We could see that 7 is common to both of them. And so there is at least one element that's common to them. So they should be represented as two circles that overlap or interlace. And for that, we have to remember that U here should be written as well in one of the corners of our rectangle. And so first, as much as possible, all the elements in common should be placed within the overlap region. So 7 is the only one that's common, so it should be placed here. And the other elements of C, which are 3 and 5, should be written inside circle C. However, 3 and 5 should be written here, but should not be written inside the overlap region. The same with 9 and 11. So 9 should be placed here and 11 as part of set B, but again, they shouldn't be placed inside the overlap region. And since they have a common element, so they are an example of joint sets. We could have 3 or more sets, but for now, we will just have it for 2 sets for now, since it's just an introduction. So I hope you learned something out of the discussion for today. And thank you so much for the invitation. And I wish you all the best. With that, TYVM, thank you very much. And a great day to one and all. God bless everyone.